Inheritance. Inheritance facilitates reusability of code by deriving a new class from an existing one. For example, you can reuse your father's property such as house, car, furniture, and so on. But then, however, you cannot reuse certain properties such as your father's qualification. Similarly, in Java, only permitted properties can be derived by the child classes. The existing class is called parent, super, or base class. Derived class is called the child or subclass. The child inherits characteristics, that is methods and data fields, from the parent. A class can only extend one base class. All Java classes are extended from a common base class automatically, that is java.lang.object. For example, if I have a class A and do not write any extends, then it implies that class A extends object class. And further, if I have class B which extends class A, then it implies that class A extends object and class B extends class A, which further implies that class B indirectly extends the object class. Now let's look at an example to understand the concept better. Here I have a class automobile which has color, max speed, and brand as its data members, and drive as its member method. And then I have class car and truck which extend or inherit from automobile. Here you can notice that color, brand, max speed, drive are inherited from the base class. They are highlighted in gray for your better understanding. A child class may add more properties and methods such as cargo bag, load and unload, and so on. Inheritance should create an easy relationship, meaning the child is a more specific version of the parent. All common properties would be here, so common properties shouldn't be defined again and again. Inheritance would give us the power to reuse the code. Now let's look at an example. In Java we use the reserved word extends to establish an inheritance relationship. Here is an example. Class car extends vehicle. Here extends is the reserved word used for establishing the inheritance relationship between class car and vehicle, where vehicle is the base class and car being the derived class. Derived classes cannot access private members of the base class. As discussed earlier, only permitted members of the base class are accessible to the derived classes. Subclasses can use super keyword to access the shadowed variables in the immediate superclass. Super.super is not valid. Now let's work on an example on inheritance. In this example, I have a class vehicle which has wheels and weight as properties and message as a method. In this method, I am simply printing vehicle message. And then I have a class car. Class car extends class vehicle. This class has an additional property passenger load, and a method message where I'm printing car message. Here is my main class. At line 20, I'm trying to demonstrate another important rule of inheritance. That is, a parent class instance can hold the reference of a derived class object. Here, vehicle is a parent class instance, and new car returns the object reference of the derived class car to vehicle. On calling the method vehicle.message, the control moves to the method message in class car. Here I am using a keyword super to access the shadowed method message in the class vehicle. Super.message. The super.message would direct the control to the method message in class vehicle. On executing this program, the output would be vehicle message and car message, as you can see here in the output window. Constructors revisited. A method with the same name of the class and return type is not considered a constructor. Such a method is considered as a regular method by the compiler. Constructor's body can have an empty return statement, though void cannot be specified. This calls another constructor in the same class. It can be used only from within a constructor. Super calls the constructor in the parent class. Super or this call must be the first statement in the body of a constructor. Now let me explain you a little about this operator. This is an operator in Java which refers to the current object. Now the question is when to use this operator. Imagine a method which shadows the class variable with the automatic variable. In such a situation, this can be used to refer to the current class variables. In this example, I have two class variables, int myInt and int myVariable. I have a method which has a parameter int myVariable. The parameter is shadowing the myVariable which belongs to the class. If I declare another variable int myInt is equal to 10, now this variable is considered to be automatic variable. However, even the parameters are also considered to be automatic variables. If I were to assign myInt variable to the class variable myInt, then I would not be able to refer to the class variable without using the this operator. When I say this dot myInt is equal to myInt, it implies that this dot myInt refers to the class variable and only myInt refers to the automatic variable. In the same manner, this dot myVariable refers to the class variable and then myVariable refers to the automatic variable. A few important points to remember. This operator is not available for static methods or blocks. All variables declared inside a method or block are automatic variables. Here is an example which shows how the derived class objects are created. In this example, I have three classes: Tom, Cat, and Animal. Tom extended or inherited from Cat and Cat inherited from Animal. When I create an object of class Tom, highlighted in blue, the control first moves to the Tom's constructor. From here, Tom's constructor implicitly calls the superconstructor. Therefore, the control moves to the Cat's constructor. Because Cat is extended from Animal, the Cat's constructor also calls the superconstructor, passing the control to the Animal's constructor. Here, as Animal is not extended from any class, the statement in the Animal's constructor are first executed. Further, the statements in the Cat's constructor are executed. And finally, the statements in the Tom's constructor are executed. This proves that the base class objects are created before the derived class objects. The output is in Animal, in Cat, and in Tom. It's time for us to work on the examples before we move forward.